Diamonds. 4 billion years old, and they still dazzle us. But these rocks aren't just for show anymore. Hidden inside are powers that could change your life.
The future of diamond is very exciting and opens up what many of us have been calling the new diamond age.
To reach that shining future, scientists have to outdo nature and build a better diamond.
The new synthetic diamonds, that's a technology that's going to take us places we've never been before.
It's a dazzling challenge. Can science do the unnatural and make a super diamond? Diamonds are like no other substance. They're 4 times harder than any mineral on the planet. They resist corrosion. The best are completely transparent. And they conduct heat. Some can conduct electricity.
What you have is a material such as diamond that has a fantastic range of unique properties, and it's the combination of these unique properties that makes diamonds special.
If science can harness the powers of these stones, it could revolutionize our lives. From the microchips in our phones to the machines that explore space.
They'd be super durable, they'd last forever. They'd be resistant to heat and cold and the other kinds of extremes.
It's said diamonds are forever, but they aren't. Most contain natural flaws, flaws that can't withstand extreme heat and pressure. To transform technology, science must do something unnatural. Create the ultimate diamond in the lab.
Nature is the guideline, and the question is, can we improve upon it? The race now is to produce a super diamond.
A super diamond would have all the properties of a natural diamond, but could be manufactured in any shape or size. Most of all, they would mimic the properties of the rarest gems, like this one. The Hope Diamond. Perhaps the world's most perfect natural diamond. It's kept behind bomb-proof glass in the Smithsonian Institution in Washington, D.C. At 45.5 carats, this gem is over 100 times bigger than the average diamond ring. It's one of the largest and most valuable diamonds ever discovered, worth around $250 million. But that's not all. This gem has some unusual properties that highlight what makes diamonds so special. Jeffrey Post, the curator of the National Gem Collection, is researching this stone. In the lab, he demonstrates a phenomenon that sets the Hope Diamond apart from most others.
We can take an ultraviolet light and we can expose the Hope Diamond to the ultraviolet light, and we'll leave it on for about 10 or 15 seconds. Also notice that one of the white diamonds on the outside fluoresces very bright blue. And so now we're going to turn the room lights off, and I'll turn off the ultraviolet light, and we can see the intense orange glow, the property called phosphorescence.
For years, this glow was attributed to a curse cast over the diamond when it was stolen from an Indian temple centuries ago. But Post isn't superstitious.
So here you've got supposedly a cursed diamond that glows this blood red color. Well, you know, that's a great story in itself. But then the scientist in many of us says, well, why does it do that?
Post and his team investigate using a spectrometer, an instrument that analyzes wavelengths of light. The spectrometer shows that the Hope's distinct hue comes from two colors: aqua and red.
3, 2,
The team can now identify two chemical elements in the diamond: boron and nitrogen.
Suddenly, now I understand what is going on when this diamond is phosphorescent.
Boron makes the stone blue. When combined with nitrogen, the stone shines red. Chemicals, not a curse, make the Hope glow. It's not the red glow that excites scientists, but the element that makes the Hope blue: boron. Boron does more than color diamonds. It also allows them to conduct electricity.
Blue diamonds, because of the boron present in them, are in fact semiconductors of electricity, which makes them very different than other diamonds that are pure carbon.
Pure white diamonds are electrical insulators. Try to pass a current through them, and nothing happens. But blue boron-rich diamonds, like the Hope, are electrical conductors. The extra atoms of boron interact with the existing diamond atoms, letting an electrical current pass through. But all diamonds, not just blue diamonds, have another useful property. They transfer heat better than any material known. If science could make synthetic diamonds that both conduct electricity and transfer heat, they could revolutionize a critical component of daily life: the semiconductor. Semiconductors are the vital component in nearly every electronic device. In transmitting electricity to the precision control of microchip technology. For the past 50 years, these devices have been made almost exclusively from silicon. But silicon has a major drawback. The more electricity it carries, the hotter it gets. The result? Most silicon chips require complex cooling technology. If they exceed about 300 degrees Fahrenheit, they'll shut down.
One of the huge hurdles that are facing manufacturers is that they have to be able to remove the heat away from these electronic systems. You know, think of your own laptop at home as you're operating it. It gets hot. And so this becomes a big problem. Right now they're using metals mostly to do that. But diamonds, in fact, are much better conductors of heat than metals are.
With the discovery that blue diamonds transfer heat and conduct electricity, scientists can imagine the unimaginable. A world beyond silicon. A world where everything from your cell phone to a spacecraft runs on diamonds. Diamonds can carry 30 times more power than silicon and operate 3 times faster. And they're so efficient at transferring heat, they could run a computer at speeds that would melt a silicon chip. They also resist temperatures over 1,800 degrees Fahrenheit.
To be able to coat electronics with diamond or use pieces of diamond as the heat sinks would certainly offer a whole new direction for the manufacture of even smaller, more powerful electronic devices.
Despite their eye-catching sparkle, diamond's real potential has been overlooked for centuries. The possibilities for technology are almost endless. But there's one problem. Diamonds are rare and expensive. Natural semiconducting diamonds like the Hope are thousands of times more rare.